Good morning. Welcome to e-learning. I am P. Saktivel, Assistant Professor, Department of EEE, Thandai Periyar Government Institute of Technology, Vellore. Today's topic, MOSFET. A metal oxide semiconductor field effect transistor is shortly known as MOSFET. MOSFETs are developed by combining the areas of field effect concept and MOS technology. MOSFET has three terminals called drain, source and gate. In the MOSFET also, the arrow indicates the direction of electron flow. Types of MOSFET. There are two types of MOSFET, N-channel MOSFET and P-channel MOSFET. So, in the N-channel MOSFET, the arrow is towards inside, and in the P-channel MOSFET, the arrow is towards outside. Symbol for the MOSFET. So, it is the symbol for N-channel MOSFET, it is the symbol for the P-channel MOSFET. About the MOSFET, MOSFET is a voltage controlled device. MOSFET is a unipolar device. Unipolar device means its operation depends on the flow of majority carriers only. That is known as unipolar devices. Its input impedance, that is gate circuit impedance, is extremely high in the order of megohms. So, it can be used in low power high frequency applications such as SMPS. SMPS means switch mode power supply. Types of MOSFET: N-channel enhancement MOSFET and P-channel enhancement MOSFET. Among this N-channel enhancement and P-channel enhancement MOSFET, because of higher mobility of electrons, commonly N-channel enhancement MOSFETs are used. It is the cross-sectional view of N-channel enhancement MOSFET. See here, this is the substrate which is made by P material, P substrate. Here the terminal is drain, here the terminal is source. Both drain and source are made up of N plus, that is heavily doped N regions. Construction of MOSFET: on P substrate, two heavily doped N plus regions are diffused. This is P substrate. Two heavily doped N plus regions are diffused. SiO2 insulating layer is grown on P substrate. On this P substrate, we should grow this SiO2 oxide layer. That is SiO2 oxide layer is also known as insulating layer. For the full length, we grown the oxide layer. For this full length, we grown the oxide layer. But in order to facilitate this drain and source, we should etch the SiO2 layers above this N plus doping region. Here, this oxide layers are etched. Only oxide layer is present here. Over this oxide layer, we should frame a metal. See here, this is black things are known as metals. These metals are used for connections. Here, when the gate is open, the junction between this N plus drain and this P substrate, this area, this junction is reverse biased by the input voltage. So, no current can flow from drain to source. So, next, when the gate is made positive with respect to source, when the gate is made positive with respect to source, electrons forms N minus channel in this area. Electrons forms N minus channel below the gate layer. So now the current can flow from drain to source through this N minus channel. So only this is known as N channel enhancement MOSFET. The diagram shows the transfer characteristics. Transfer characteristics is the graph drawn between the drain current versus gate to source voltage. The graph drawn between the drain current to gate to source voltage is known as transfer characteristics. When this gate to source voltage reaches a threshold level VGST. After reaching this threshold level only, that N minus channel will be established. After that only the current flows from, see here, after the threshold level only, here N minus channel is established, then only the current flows from drain to source. Next, output characteristics. The output characteristics is drawn between drain current and drain to source voltage, where VGS is a parameter. Here it is the graph drawn between ID, that is drain current, and drain to source voltage, where VGS is a parameter. Now this red line shows the load line. This load line intersects the output characteristics at point A and also at point B. At point A, it acts as an on switch. At point B, it acts as an closed switch or off switch. At point A, it acts as an on switch. At point B, it acts as an off switch. In this output characteristics, we have the cutoff region and saturation region. Here we have the breakdown region. This diagram shows the switching characteristics. So MOSFET is a voltage control device. So in order to control the operation of the MOSFET, we are applying the gate voltage. This is the gate voltage. After this gate voltage, we are increasing the gate to source voltage. So this graph shows gate to source voltage, and this graph shows the drain current. See here, during the turn on process, the gate to source voltage takes some time to reach this threshold level, that is VGST. The time taken to reach the gate to source voltage to a threshold level is known as delayed time, turn on delayed time. After this threshold level, that is the time taken from the VGS to VGSP, the time taken by the gate to source voltage to increase from this VGST, that is threshold level, to VGSP. VGSP means gate to source voltage pinch off voltage. So the time taken to reach from threshold level to pinch off level is known as raise time. So this V1 is the hot saturated value. Similarly, this turn off time consists of turn off delayed time and fall time. Turn off delayed time is the time required to reduce the VGS from V1 hot saturated value to the pinch off value, that is VGSP. So the time taken by the gate to source voltage to reduce from odd saturated value V1 to this VGSP is known as turn off delay time, and the time taken by the gate to source voltage to reduce from this VGSP to VGST, that is from pinch off voltage to threshold voltage, the time taken is known as fall time. Switching characteristics, that is T on, TDN. See the formula, T on is given by TDN plus TR, where TDN is turn on delay time is the time during which the input capacitance charges to gate threshold voltage VGST. So up to the charging of VGST, the time is known as TDN. Next one, TR, raise time is the time taken for gate to source voltage, that is VGS, to raise to pinch off voltage, that is VGSP. And what is V1? Overdrive voltage. Next one, switching characteristics, that is turn off time. Turn off time is given by turn off delay time plus fall time. Turn off delay time means TDF is the time during which input capacitance discharges from overdrive gate voltage V1, overdrive gate voltage to VGSP. See here, this is overdrive gate voltage. The time taken to reach this VGS from overdrive gate voltage to VGSP, that is pinch off voltage, is known as turn off delay time. And TF, that is the fall time. TF is the time during which the input capacitance discharges from VGSP to VGST, that is this time taken to discharge the capacitance from VGSP to VGST, that is VGST means threshold voltage, is known as fall time. Thank you.